up to this point, we have modeled our simulation process. So after the sealer process, what happens? So let's just check the PDF file once again. So after the sealer, yes. So after the sealer process, 9% of the parts leaving the sealer process are going to be assumed as faulty objects. Okay, they have quality problems, so they need to get into the rework process. But remaining 91% are going to be assumed as qualified. Okay, so they are going to pass through the inspection process. And the inspection process does not take any time. Therefore, we are going to separate ways of these parts. Okay, so we are just going to decide when a part, either part A or part B, it doesn't matter. Whenever a part leaves the sealer process, we need to decide if it is going to rework or directly shipping. Okay, so we are going to use a decide module here. After the sealer process, while sealer is selected, if I choose the decide module, here the decide is going to separate the ways of entities based on different aspects. Okay, so we can use this decide module in many different ways. So this is one way of using it. So I'm double clicking on that, and the name of the decide is going to be a question. Okay, so question. I mean, this is not a necessary thing to do in arena modeling, but in order to understand what you are doing and anybody to understand what you are doing, okay, maybe it is a good idea to write a question here. So we need to write here, failed sealer inspection. So it's a question mark. Failed sealer inspection. So did this part fail the sealer inspection? Okay, so this is the question. Did this part fail the sealer inspection? And it has two-way by chance. The answer is two-way by chance. And the probability that it is going to be true is simply going to be 9%. Okay, so the percentage, you can write anything here. So the probability that it is going to be true, the answer is going to be true with 9%, right? Because these are the ones which failed the sealer inspection. Okay, these are the ones which are successful. So with 9% probability, they are going to fail the sealer inspection. And if they fail the sealer inspection, okay, so you see we have true and false here. Okay, if it fails the sealer inspection, then it is going to get into a rework process, right? A rework process. So while the decision module is selected, I am going to introduce another process here, which is going to be named as rework process. Okay, it is going to be named as rework process. And again, it's the type of seize delay release. It has a logic type of seize delay release. And the resource that it is going to seize is going to be what? The rework machine. The rework machine. And it is going to seize only a single rework machine here. So we click OK. And the delay type here is what? Exponentially distributed with an average of 45 minutes. So the delay type is an expression given in minutes, which is expo 45. Okay. So we have the rework process here introduced here. Okay. Now this is the end of the production processes. Now after the rework process, we know that 20% of the rework parts are going to be scrapped, but the remaining 80% are going to be successfully completing the rework process, and they are going to be salvaged. So after the rework process, again, by 20-80% chance, the materials are going to be either scrapped or salvaged. So I am just going to add another decide module here while the rework process is selected. Again, in this decide module, I'm going to write a question. Failed rework inspection, and the answer is going to be true again by 20% chance. So Does this rework part fail the reworked inspection? The answer is yes by 20%, two-way by chance. By the way, you can create n-way by chance as well. So you can create 3 or more than 3 paths outside this decide module, not every time two-way. Okay? And you can also use these decide modules by conditioning, but I'm going to show you these in our future applications. So by 20% chance, the rework parts are going to fail. And now I am going to do what? I am going to dispose the products. Okay? They are going to be disposed. Now let's make these disposals in the beginning. So I select this decision module. Anything that does not fail the sealer inspection will be shipped, right? So I am going to choose that decide module and introduce a dispose module, and the name of this dispose module will be shipped. Okay, shipped. And anything that fails the rework inspection will be scrapped. And anything, so I selected decide module. There is another exit from this decide module with false answer. Anything that does not fail the rework inspection will be disposed as salvaged. Okay, so I have 3 disposals here. So I have created my simulation model here, but one thing is missing. So one thing I have forgotten. So what is that? Remember now, in the requirements of this question, it is asking, we want to collect statistics in each area on resource utilization, so we can get that. We can get that as the statistic in the statistical records. The number in Q, time in Q, we can get also these in Q statistics, and the total time in the system separated out by shipped parts, salvage parts, and scrap parts. Now this is missing. How are we going to collect the total time in the system for each part? Now we need to collect separate statistics in this path, and in this path. Okay? So I'm just going to take this next to each other to see better. So I need to collect statistics related to scrap parts, how much time that they have spent in the system, how much time the salvage parts spent in the system, and how much time the shift parts spent in the system. And I need to calculate the average of this. Okay? Now, how do I do that? How am I going to do that? I am going to use a module called record. Okay? So, for example, let me erase that connection here. And before disposal, I am just going to create a record for those entities in that record module. Then I am going to dispose them. So again, this record module is not going to take any time for the item, for the entity. However, it is going to record a statistic about it. For every entity that goes through this record module, for that entity, we are going to record a statistic, which is going to be the total time that it spends in the system. So the name of this record module will be record scrapped parts. Okay. And the type of the record that I am going to do is going to be introduced here. I am going to introduce what type of statistic that I am going to introduce. Remember now, in Arena, there are different type of statistics, which are counter statistics, time persistent statistics, and the tele statistics. So what I am going to record here is basically a type of time interval. Okay, time interval statistic. Okay, so I am just going to use the time interval statistic here, and the record here is going to calculate the time interval between my arrival time attributes and right now. So whenever an entity, so I cannot unfortunately take this window outside. So whenever an entity goes through this record process, for that entity, the time interval between my arrival time and the time that it goes through this record module will be recorded, and that is going to be recorded on record scrapped parts. Okay, that is going to be recorded on record scrapped parts. So you can write anything here. Okay, you can write, for example, not record, but system time scrapped parts. Okay, system time for scrapped parts. So what is it? The time between the time interval from my arrival time, which is an attribute written on that entity. Remember, we have done this in the beginning. And the time between the current time. Okay, the current time that it goes through this record module. So when you click on OK, we are going to see record statistics on scrapped parts about the total time that they spent in the system. Now let's do the same for this and these parts. Okay, so why I select this decision module, I will introduce a record module from the basic process panel, and I'm going to connect it again to salvaged. So this time I will say record salvaged parts. So I will choose time interval once again. Again, we are going to check the difference between my arrival time and the time that it goes through that record module. The tally name here, so remember, this is a type of tally statistic. What is a tally statistic? Which is basically the time spent in a process or the time spent in the queue. Okay, so the duration, tally statistics are duration of times. Okay, so or basically sum of duration of times maybe. Okay, so this is a tally statistic, and the name of this tally statistic will be system time for salvaged parts. Okay, so click OK, and finally we are going to add another record module. There is another exit here, as you can see, which are not failing the sealer inspection, which are successfully completing the sealer inspection. So these are going to be recorded as well in record 3. We are going to change the name of that record as record shipped parts. And this record that we are going to have is a time interval between my arrival time again. Okay, so I should not leave any space here because I have not. And the name of the tally is going to be system time for shipped parts. And that's it basically. Okay, so I think I'm done. This is the end of the last thing that I am supposed to do. Okay. Okay. Now again, in the run setup here, the project parameters, we have written the name of the project here. I can my name here, analyst name, and I can write a description here as I have told you. And I would like to see statistics related to queues, processes, entities, and resources, etc. And I think I am ready to run my simulation. Now, let's run it before analyzing the results. Let's run it with the slowest animation possible. So do you see the slowest animation? So you see part B's are arriving in batches of 4. Therefore, we have 7 in this process. 4 of the, so because the parts are arriving in batches of 4 every time here. So you see right now, only 8 of these parts have arrived. Okay. So you see it's increasing 4 by 4. Increasing 4 by 4. Okay. But this is increasing 1 by 1. Okay. And you see there is a very, very long queue in Prep A and Prep B processes. Not very long, but on the average. In rework process, we also observe a queue. But in sealer process, usually the size of the queues are smaller. Okay. Now I am going to do this thing. I am going to, I mean, as you can see here, in this animation, both part A and part B, they are shown with the same picture. Now, they enter in the sealer process queue here, part A and part B, but I do not understand which is part A or which is part B in that simulation, in that animation, because the picture report here, report pictures here used are the same for both entities. So how am I going to change that? So let's do that. Stop the animation. And here we have assign modules, right? So these assign modules are created as soon as the parts enter, right? So just as they enter, we are having an assign module here. First of all, let me show you the entities here. Okay. You can actually change the picture of the entities from here. Okay. So for example, for part A entities, let's see a picture of a blue ball. Okay. For part A entities, let's see a picture of blue ball. And for part B entities, let's see a picture of a red ball. Okay. Red ball. Okay. So from entity, you see from entity spreadsheet module here, I can change the picture of the entities. Okay. Now let's rerun the simulation. Now it is better, right? So if I see anything in the queue of sealer process, I am just going to stop, but I mean, because it is too fast. It was just too fast. Okay. So you see, you have red balls and blue balls simultaneously in the queue. Sometimes they are red, sometimes they are blue. Sometimes we have two balls, one of them is red, one of them is blue. So it depends on the queue of the sealer process. You see multiple balls, and also in the rework process here. Okay. So right now, there are how many parts? So right now, there are 8 parts in this module. One of them is being processed. The remaining 7 of them are in the queue. In the first 4 of them, we observe part Bs, and in the last 3, we observe part As. So if you continuously observe, you will see that other type of parts are also coming. So you see a part B between part A parts. Okay, so the animation is going to will help you to understand how the system behaves. Okay, so animation is a good thing here. And you need to understand how you can use the animations. Okay, by the way, you can change the entity pictures with the assign module as well. So I would like to show that to you as well. So let's just say the part A's are arriving as a blue ball. Okay, you see the entity of part A is having a blue ball. Let's just say in this assign module, we introduce another attribute. And that attribute is going to be the entity picture. And we are going to change the picture during the processes. So you can change the picture of an entity in the middle of a process as well, not just in the beginning. So this does not mean the picture is going to stay the same from the beginning to the end. So let's just change it to the picture of a yellow ball, okay? So the part A will be created as a blue ball. However, as it goes through this assign module, it is going to be converted into a yellow ball. Okay. Was it a yellow ball, really? So let us see it here. Yes, I mean, this color is yellow, my friends. Okay, seriously. This is a yellow color. I can't believe it, but it is yellow. Yes. So you see, you can change, but the entities here are created as blue. If you are careful, I mean, let me show you the slowest way here. Okay, the colors are blue here. They are going to be changed in red. Okay, so let me erase that. Okay, the entity picture change. Let me delete that so we can have blue balls at all times. Okay, so this is the end of the simulation. So we have run this system. So let us show the results. So remember now in our parameters, replication parameters, we have a replication length of 32 hours, only one replication. Most probably we are not going to get any um, confidence interval for the performance statistics. So you see here how many minutes we have spent in the simulation. So let's make it a little fast. So 32 hours means 1920 minutes. Now it has been complete. While it was complete, so I will see the results, but I'm going to do it later. So while the simulation terminates at the 32nd hour, 417 part A's arrived, 248 part B's arrived. How many parts have left the system? The number of scrapped departures is 4, number of salvaged departures is 32, and the number of shipped departures is 589. Okay? So you can also see these counts. So in a decide module, how many have left the decide module with an answer of yes and with an answer of no? You can see the same in the decide module as well. So 61 parts, they have failed sealer inspection. However, 25 of them are still in the process, waiting in the queue. 24 of them are waiting in the queue. The queue animation is not long enough to see these all 24 parts here. Only you can see a few of them. And 36 of them, so 36 of the 61 have left the rework process either by failing the rework process or either by being salvaged. So this is the end of the simulation. So from the reports here, you can see the category overview and you can see the results. So let's check the results of this system. Now, what does the question ask? So let us remind ourselves with the question requirements. It says we want to collect statistics in each area on resource utilization. So let's start with the resource utilization now. Okay. So you see, we have, let me go back to report. So we have resource here. Okay, resource. Under the resource, we have the usage statistics and instantaneous. If you check the instantaneous utilization here, you will see that machine at preparation A process, which is prep A machine, is used in 90% of the time. Prep B machine is used in 75% of the time, approximately. Rework machine is used in 94% of the time, and sealer machine is used in 86% of the time, approximately. So this is 95. So these are the instantaneous utilization values. The scheduled utilization values are the same as well. So again, there is no difference in this example as well. And there is a plot diagram which shows the utilization rates of each resource colored by color here. So let me make zoom in a little. I don't know how am I going to zoom in. I am sorry. So yes, it's here. So I can say 150. Yes. So you see, this is prep A machine, this is prep B, this is rework, and this is sealer process, sealer machine. The utilization of the resources are like this. So we do not have a fair system here. If they were not machines, but if we have people working in these processes, you see the person who works in the rework process is working in a larger percentage of time, while the person who works in the prep B process is working only in 75% of the time. So this is not a very fair system in utilization sense. Okay? But what you gonna do? I mean, no system is perfect in that sense. No system is that fair. So this is a statistic related to resource usage. Okay? Now, let's talk about the number in queue. So in each queue, what is the average number of entities that are waiting? So how do we see that by queue statistics here? Under the queue statistics, we have the other statistics here, number waiting. So in prep A process queue, the average number of entities waiting in queue is 3.16. In prep B process queue, the average number of entities waiting is 3.50. In rework process queue, it is 12.95. And in sealer process queue, it is 0.86. Okay. So you remember the animations. You remember the animations, my friends, right? So in the animations, we were observing queue here and observing a queue here, but we were observing a queue less frequently here. Okay, it was not very usual for us to observe a queue here. Therefore, the queue size of the sealer process was not very long. Therefore, the average queue size is also not very long. But in the rework process, there is an unbelievable queue here. Therefore, the average length of the queue for the rework process is the largest. Okay, so we observe a very, very large queue size here. So if you want to improve this system, if you want to improve the bottleneck of this system, I think it's a good idea if we increase the number of rework machines here. Okay, so we do not observe many queues here. So we do not observe many inventories. You know, queue means inventory, right? So if the size of the queues increase, then this means the average inventory level increase. And if the average inventory level increase, then this means inventory costs are increasing. So this is how simulation is related with inventory management. Okay. So in this process, I recommend you to introduce another rework machine here, a parallel machine, another rework resource here to improve this system so we do not observe a large amount of inventory in the queue before the rework process. So this is somehow the bottleneck of this system. So we can improve this bottleneck so we can reduce the inventory cost, because for the time that the items are spending time in the system, they are creating inventory costs. Okay. So we are just going to continue to analyzing our report. So we are going to analyze the number in queue. The average number in the queue can be observed in here, the number waiting in the queue. The longest queue is observed in the rework process. Now, the next statistic is the average time spent in the queue. The average time spending or the average waiting time in queues for prep A, prep B, rework, and sealer processes are like this. The average time spent in the queue is the largest in prep B process. Why? Because the parts are arriving in batches of 4. And the total time in the system. Now, if you check the entity reports and under others, you will see that the total time spent by part A and part B, by entity types. So the total time spent in the system is separated out by entity types here. So the part A is spending 55 minutes on the average in the system, and part B's are spending 60 minutes on the average in the system. However, if you remember the question here, it says that you need to separate out the total time in system by shipped parts, salvage parts, and scrap parts. So where do we see that? Because we have created record modules for that in the simulation model flow chart. So we have a user specified statistic in the report, okay, which is the interval system time salvage parts, system time scrap parts, and system time shipped parts. So when you use the record module, the statistics collected by the record module will be reported under user specified section in the reports category overview. And that is a 30 statistic, which is a time interval. And you see the average time spent by the shipped part is 28 minutes. Okay. So here's the thing. Let me show you the model again. So we have 3 paths here, right? So the parts are arriving from here. Some parts are using the bottom path here, which is the path of shipped parts. The scrap parts, the parts which are scrapped, they are spending 737 minutes on the average. And the salvage parts, they are spending 503.85 minutes on the average. Okay. So you will see here, so the parts, I'm sorry. So 737 for the scrap parts and 503 for the salvage parts. So there is a 250 minutes difference between these two. So let me show you why this is happening. So actually, you may say that, I mean, whether it is salvaged or scrapped, they are spending time in the rework process, right? So how the average times are different? Actually, the average time should not be different. However, because in this short simulation, we only observe 4 observations of the scrap parts, the results are not reliable, okay? So we need to increase the length of this simulation procedure, my friends. The results here are not reliable. So actually, according to these results, as I have told you, the time spent in the system by salvaged and scrap parts should be approximately the same. The averages should be approximately the same. However, my friends, because we only observe 4 observations for the scrap parts, the results are not very reliable. So in the longer simulation, in a long run of simulation, we are going to observe what? We are going to observe much more reliable results. So in these cases, these two averages should be very close to each other.